Hello everyone, welcome back to another session of Python tutorials. So in this video, we are going to see the programs on decision making and looping constructs. So in decision making, we'll see how to use if else, and then we'll see nesting of ifs, and then nesting of if and else, and then we'll see if, elif, and else. So these are the things that we'll be covering in the decision control. Now coming to the looping structures, in the looping structures, we'll see there are two looping structures. The first one is while and the second one is for. So we'll see how to use for and while in the program. So in the variations of while and for, we also will see how to use nesting of while, and also we'll see how to use nesting of for. We also will look into the concept of how to use associate else with while and for. So that's a concept that is there in Python. You can associate an else with the while and for. So these are all the things that we are going to see today in the programs. Okay, so let us start with the simple if. So herein, I am reading in a number. So I'm saying n is equal to, so I'll be reading an integer number. So I'll say input and then enter a number. So the user will be, we are prompting the user to enter a number. So the user will be entering a number. So after the user enters a number, if you want to check whether the number is even or odd. Okay, so I am just, I want to check whether the number is even. Okay, so I am saying if n, okay, mod, so modulus is an operation that will give the remainder as a result. If n mod 2 is equivalent to 0, then you can say that the number is even. So I'm writing print, I'm saying the number is even. I can just say n comma, so I'll say is even number. So this is how I can simply write an if statement inside a program, wherein the execution of the program will be, the path of execution of the program will depend on this particular condition. If this condition evaluates to be true, this print statement will print on the screen. Okay, so if this if condition evaluates to be false, then this print statement will not print on the screen. So the execution or the path of execution, path of the executable statements will depend on the condition over here. Okay, so it's a very simple program wherein we are just checking whether the given number is even or not. Okay, so even or not. So I read a number, I found the modulus of it. If it is equal, then we are saying it is an even number. Let me run and show you the output. So here it is prompting me to enter a number. So I am entering a number which is 44. Okay, so I got an answer. 44 mod 2 is evaluating to be 0. So this 0 is the remainder, right? So 44 mod 2 will give me the remainder, and the remainder is 0. If the remainder is 0 is equal to 0, then this condition is evaluating to be true. Now, because this condition is true, this print statement will execute. So what I wrote, n is nothing but 44. 44 is even number, is printed on the screen. But you can see that this is a simple if. You can use this if in your programs. Simply you can use if without an else and elif also. Okay, so this is possible. Now let me come to the second point, wherein this program here is incomplete, right? If for example I gave an odd number, so say for example I gave an odd number which is 31. Okay, so when I try to execute this, nothing is seen on the screen because this program is quite incomplete, wherein I wanted an else also here which will say that it is an odd number. So so for that your Python will give you another statement to associate with an if, which is an else statement. So I am writing an else over here. The point you need to look is into the syntax of how you have to write if and else. So there is a colon associated over here, and you can see that the statements inside the if block are indented. So you can see there is an indentation over here, and also after else also there is an indentation, meaning that it is inside the else block. So I'll write the same statement here, but I'll say now for this I'll say that it is an odd number. So I'm saying it is an odd number. So now let me run and show you the program. So say I'm giving 11. So 11 is an odd number. So you can see that it is saying 11 is odd number. And when I execute it for the even number, it will say that it is even number. So I gave 78 and then it is saying 78 is even number. Now you can see this if and else my program is actually complete. Okay, so this is how you can associate if with an else. But remember that, say that I'm not giving any if over here and I'm simply using an else, and let me show you the execution what will happen. So here it is saying that else cannot be used independently. So it's a syntax error if you are trying to use an else without a if. But you can use if without an else. Okay, simply you can write an if statement and leave it off in your code, like you can write your own logic without an else, it is okay, but you cannot have an else without an if. So if should always have an um, uh, else should always have an if preceded before it, okay, not after it. After it I cannot write. So say I'm having an if over here, so I'm saying mod 2 is equal to 0, and I'm writing a print statement over here saying that n is even. So this do not work. It should be before that else only. Okay. So the if that we are talking about should be before the else only. Okay. So this order is also not correct. I should have if and then followed by an else. I can individually have an if. Okay. I cannot individually have an else. If I'm having an else, prior to that, I need to have an if or else an else. Okay. Fine. So this is regarding if and if else. Okay, so now let us look into how to give a nested if. Okay, so say for example I want to find out the greatest among the three numbers. So say I have three numbers, so let me read in three numbers. So this is A. Okay, so I'm reading in A, and in the same way I'm reading in another number which is B, and in the same way I'm reading in another number which is C. Okay, so this is B and this is C. Okay, and I want to find out what is the program that I'm writing. So I want to find out the greatest among the three numbers. Okay, greatest among the three numbers. Fine. Okay, so this is A and this is B, and okay, so this is C. Okay, so now that we have written, we have read the three numbers from the user. Now let us write the logic. Okay, so first I am checking if A is greater than B. Okay, so if A is greater than B, now again I am checking whether A is greater than C. Okay, so if A is greater than C, then what I am doing is I am saying that A is greatest, because A is greater than B as well as A is greater than C. If both the conditions are true, then it means that A is greatest. Okay, so here I'll say A is large or greatest or big number. Okay, so A is large of all. Okay, so largest. So this is what I have printed, and in the else part, okay, so what I'll do is it means that if A is greater than B, but A is not greater than C, meaning that here A is greater than B means that B is smaller than A. Here A is greater than C becomes a false, means that C is largest. Okay, fine. Meaning that B is smaller than A is smaller than C, meaning that it is also B is also smaller than C. Okay, that's why what I'm doing is I'm writing that C is largest. I hope everybody understood here. Let me show you this. Let me explain you the logic. Okay, so now here when I said A is greater than B, means that, so I'm having three numbers, right? So I have A, B and C. Okay, so when I say A is greater than B, okay, so now B is out of race. Okay, so this condition is true, right? So if this condition is true and I'm entering inside it, now I am checking that A is greater than C. Okay, so whether A is greater than C. Okay, so if this condition is true, meaning that A is greater than C, this condition is true, meaning that A is greatest. Okay, so it is greater than B as well as it is greater than C. Okay, now let us look into the other way around. So what is the other conditions over here? The other conditions are, like I am saying, A is greater than B. This condition is true. Okay, but when you came inside, this condition is false, meaning that A is less than C. Okay, so if this condition is false, meaning that A is less than C. Okay, when A is less than C, here you can see A is greater than B, meaning that the order is C is greatest, then A, then B. Okay, so this is the order. So C is greatest. Okay, so I have printed C is greatest over here in the else part. Okay, so this is how you can actually write your logics. So now what I'm doing is, so I'm writing another else over here to check whether B is greater than C. Okay, so I'm saying B is greater than C. Okay, so when A is greater than B is checked, in this case, if B is greatest, then all this will not execute and directly the control will come to the else part. If this condition becomes false, what happens is the control will come to this particular else part, meaning that B is greater than A. Now you have only one condition to check, which is B is greater than C. If B is also greater than C, then what you can do, you can say that B is largest. Okay, so else you already know that A is smaller than B, but here you found out that B is smaller than C, meaning that C is the greatest. Okay, so I'll be writing C is greatest. So this is the logic, friends. The concept over here is we have used a nested if else. Okay, so you can see I have used if inside an if. So this is the outer if, and you can see that this is the inner if. The inner if, the control comes to the inner if only if the outer if becomes true. If this condition becomes true, then only the control will come to the inner if. Okay, so for if inner if becomes false, then I also have associated an else over here. So this, to come to this particular else, it means that this has to be true and this if has to be false. Okay, for this if to execute, it means that this has to be true and this also has to be true. Okay, fine. For this particular if to execute, what should happen? This statement should be false. Okay, right. For this else part to execute, this statement should be false, this statement should be false, and this statement should be false. Then only this part will execute. Okay, so this is how we have written the logic. Okay, so this is an if and else. Inside this if, you are having an if and else also. Okay, so let me run this program and show you. So enter A. So let me enter A. So A is 23 and B is 34, and then I am saying C is 67. So it is saying 67 is largest. Okay, so now that I have shown you for C, let us debug the program and check whether it is greatest for B or not. Okay, so I gave 77 and for C I just gave 1. So it is saying 77 is largest. Let us again check for A whether we are getting the correct answer or not. So I gave 111 for A, and then I gave 34 for B, and then I gave 23 for C. So you can see 111 is largest. So our program is working fine and we are able to get like which is the largest. Okay, so this is wherein we have finished the concept of if else and nested if else statements. Okay, so now let us look into the concept of how to give elif. Okay, if and elif. For this, what I'm doing is I am trying to take read a number string from the user. So I'm saying C is equal to, so I said input. So by default, this input will give us a string. So I'm asking the user to enter the string. So enter the string. So the user will be entering the string, and this string we are going to find out what is the type of this string, whether this string is alphanumerical or it is all digits, or that we are going to find out what is there in the string. So I'm writing an if condition wherein I'm saying C dot. So I'm using the built-in function, so which is digit. So digit will check whether all are digits or not. So this is digit, and then I am writing a print statement saying that if this condition is true, then it means that the string C, okay, so I'll say C is all digits, okay, fine, okay, so this is what we have written. And if this condition is true, you don't want the rest of the conditions to execute. But if you are giving all ifs, what happens is, even if this is true, the rest of the ifs also will keep executing. So to actually reduce execution time, you can write your logic in this way, that if this if condition becomes true, the rest of the ifs, if you don't want to execute, you can write an elif. That's the difference between having a if ladder and then if and elif. Okay, so the difference is that if you're having an if and then ifs and all that like this, what happens is, even if this condition is true, this condition is also checked. This condition is also checked for the if statements. Okay, if you are giving an elif, what happens is, if this condition is true, the rest of the conditions will never execute. Okay, so that is the difference between having a if ladder and elif. Okay, fine. So I don't want, I already have, if this condition is true, meaning that the string is having digits. So there is no meaning in checking with the other conditions. So that's why without if, I am preferring elif. Okay, so I'm writing elif, then C dot, I'm saying numeric. Okay, so I'm saying numeric function. Okay, so if it is numeric, then I'm saying the difference between digits and numeric is that digits will actually take the numbers from 0 to 9, but numeric will take all the numbers like 1 divided by 2, anything, any character that exists in your character set, all that it takes. Okay, so it is numeric. Okay, so then again, I'm taking another elif. Okay, and then I'm saying is dot C dot is alpha. Okay, so this means that all the letters are alpha characters. Okay, so I'm saying is alpha, so wherein all the letters are C is all alphabets. Okay, alphabet. Okay, right. And then I'm writing another elif, and I'm saying whether C is alpha numerical, so all num. Okay, I'm using this function. So now I'm saying that it contains alphabet as well as and numbers. Okay, fine. So this is what I have written, and finally I'm writing an else. Okay, so wherein I'm saying print, and then I'm saying thank you. Okay, so I'm saying thank you. So this is what I have written in the program. So let us see how this program works. So I'm running the program. So I want to give all numbers. So I have given 765, and you can see 765 is all digits. So you can see that as soon as I have given 765, the first condition became true. Okay, so you can see that the first condition became true because all are numericals. Since this became true, what happened is this print statement executed, and it has printed 765 is all digits. And the rest of the statements, okay, so all these statements did not execute for me. Okay, so that is what is called as if and elif. Okay, fine. So let me give you another let us see another execution. So I have given a character which is 1 by 2, and let us see what will happen. So it is saying 1 by 2 is all numeric. It's not digits. Okay, digits means only from 0 to 9. So here I have given 1 by 2, like you can see, right? So I have given 1 by 2 as the string, and now this digits is digits has become false, and then it has come to the next elif to check whether this condition is true or not. So now this condition is true. What happened? This print statement executed, and it is saying 1 by 2 is all numerical. And since this second statement became true, the rest of the statements will not execute at all. Okay, so this is how if elif works. And now let me show you the output for the third one, wherein I'll give all the characters. Okay, fine. Uh, so I'm giving Sudha now. Okay, so wherein you can see all are characters. So Sudha is all alphabet. Okay, so the third condition became true. So this became false, this became false. In that case, it is coming to this condition became true. Now the rest of this is all num and all that will not execute. Okay, fine. So now I'll show you giving characters and also the numerical values. So you can see that Sudha 1, 2, 3 is all alphabet and numbers. So this condition is true now. All these conditions have evaluated to be false. Only this condition has evaluated to be true. So C is all alphabet and numbers is executed. Okay, fine. So let me show you something else. So wherein I'm giving some and all that. So when you see that and is not a digit, is not a numerical, is not an alphabet letters, is not alphabet or digit. So that's the reason all these conditions have evaluated to be false. Okay, so you can see that this has evaluated to be false. This is also false, and this is also false. Okay, and this is also false. So finally, what happened? Whatever we have written in the else statement executed, saying that thank you. Okay, thank you is executed. So this is if, elif and else statement. Okay. Now say for example, I'm not giving this else. Okay, so I simply did not give this else. Okay, and I'm giving Sudha. Okay, so you can see that it is giving me Sudha is all alphabet. Okay, so the else part over here is not mandatory. Okay, so I can have if, I can also have ellipse without an else over here. Okay, I hope this program, all these programs are clear, and we are done with the decision making. Now we'll go into the looping structures. So there are two looping structures. The first one is a while loop and the second one is a for loop. So let me show you how the while loop executes for finding out whether a given number is prime or not. Okay, so I'm reading in a number. So I'm saying n is equal to int of, so input. So enter a number. Enter a number. So the user will enter the number. After the user enters the number, I'm taking a flag wherein I'm making the flag to be false initially. And then I'm checking whether the number is greater than 1. Okay, so I'm using for if condition over here. If number is greater than 1, then I am setting I is equal to 2. Okay, and then I'm turning the loop. So I'm writing while I is less than num. Okay, and then I'm putting a colon over here, and inside it I'm checking whether num mod I is equal to 0. Okay, so if it is equal to 0, I'm setting the flag to be true. Okay, so I'm giving the basic program for finding out whether the given number is prime or not. So now it means that there are no, there is a factor. So I'm coming out of the while loop by using the break statement. So I'm saying it is I is equal to I plus 1. Okay, and I said I is equal to I plus 1. And after that, what I'm doing is now I'm checking whether the flag is equal to true or not. If flag is equal to true, it means that it's not a prime number. So I'll say num, comma, so is not prime. Okay, so num is not prime. If the flag value still be false, then it means that it is a prime number. Okay, fine. Else we are saying that the number is a prime number. Okay, fine. Let me tell you how this works. Uh, Fine. Okay. What I'm doing here is, let me execute this and show you. Okay, fine. Okay, so enter a number. I'm entering 5. So you can see it is telling me that 5 is a prime number. So let me run it for the non-prime number. So 12. So I'm entering 12. It is saying 12 is not prime. So let me explain you how this works. Okay, fine. Now what I did is I'm taking a flag wherein it is false. Okay. And then what is while? Okay, so while is a looping construct wherein you need to have keep three things. The first one is initialization of the looping variable. So here I is the looping variable. Okay, so I have initialized I to be 2. And then this is the condition, and the condition will include this looping variable. Okay, so I is less than num. This is the condition. And whenever the condition becomes true, the while block executes. Okay, so this is the while block, and this executes only if while become true. Inside this while loop, for further iterations, okay, so this is a looping, right? You keep coming over here, check the condition, again go back, come back. Okay, so this is like executing the same set of statements again and again for many number of times. So when you do that, you need something to be done so that the iterations happen. So here you are having an increment over here, wherein you are incrementing the looping construct by 1. Okay, it can be a decrement also. Based on your logic, you will increment or decrement, or 2 times increment or 2 times decrement, or whatever you want, you can do it based on your logic. Okay, so this is what you will be doing over here. And then what I am doing is, so these are the three main constructs that the while need to have. And there should be a breaking condition for the while also, else it will go into an infinite loop. So you always have to drive it towards the breaking of the loop, and this iteration condition over here will drive this while to a breaking condition. Okay, so now let me give you the tracing. So I is equal to true 2, and say that I have given 12 as the number. Okay, so number is 12. Now what I'm doing is, so this is the value of I, right? So I'm checking the condition whether 2 is less than 12 or not. So the condition is true. So what happens is I enter into the while loop. Inside the while loop, we are saying 12 mod 2, right? So we are having this. So I'm saying 12 mod 2. If 12 mod 2 is giving a 0, as it is giving a 0. So this condition became true. So what happens is I am setting the flag value to be true, and I'm coming out of the loop, because here itself I found out that 12 is not a prime number with the first iteration itself. So I need to come out of the while loop. So break is a statement which is called as a jump statement, which is used to come out of the while loop or the for loop in the middle. Okay, so you don't want the iterations to happen to the fullest, but in the middle itself you understood that you don't need to proceed further. In that cases, you will be giving a break statement. Okay, so I don't need to proceed further, because here itself I understood that it is not a prime number, because I got a reminder, I got a factor. Okay, so I got a factor of this particular number, which is 2. So what I'm doing, I'm coming out of the loop by using the jump statement, which is break. So what happens is the iterations will stop, and the control will come to the immediate next statement after the while. So immediate next statement after the while is if flag. Okay, here I have set the flag to be true, right? So what happens, the if flag is true, then what happens is I needn't write flag is equal to true and all that, because it's a boolean, right? If checks for the boolean, so it means if true. Okay, so flag replace true for the flag, it means if true. If true, then you are saying that number is not prime. Okay, so say for example, number is equal to 7. So now I'll show you for how it will execute when the number is 7. Okay, so when the number is 7, so I is equal to 2, and what we are doing is we are iterating the loop, checking for 2 is less than 7. As it is true, so I'm entering into the while loop. Here I'm checking for 7 mod 2. 7 mod 2 is not 0. So what happens? This I gets incremented. Now I becomes 3. Okay, and the loop will go for the next iteration. So now what happens? Again, I'm checking the condition, which is 3 is less than 7. Yes, it is true. So it comes again into the yeah, while loop. Okay, so here again I'm checking for 7 mod 3. 7 mod 3 is not equal to 0. So what happens? Again, the increment happens, and I becomes a 4. Okay, Now 4 is less than 7. Yes, it is true. So what happens? It enters into the loop. Again checks for 7 mod 4. 7 mod 4 is not equal to 0. Again I gets incremented. So now I becomes a 5. Again I'm checking for 5 less than 7. Yes, it is true. So it enters into the while loop. So 7 mod 5 is not equal to 0. So again I gets incremented, becomes a 6. Okay, so 6 less than 7 is true. So again it checks the if condition. So 7 mod 6 is equal to not 0. It's not 0. So what happens? Again it increments to 7. So what happens? 7 less than 7 is false. So it comes out. Okay, because there is no use checking for 7 mod 7, because a prime number is a number which is divisible by 1 and itself. Okay, meaning that 7 is a prime number which is divisible by 1 and itself. Any number is divisible by 1 and itself, but prime number is the one which is divisible by 1 and itself only. So obviously 7 and 7 mod 7 will become 0. So our logic will fail over here. I mean, it becomes true and it becomes all that. So no need to check for 1 and 7. That's the reason only we have started iterating from 2. Okay, 2 to n minus 1. So this will happen for any number. Say you are taking the number 13. So what will happen? We'll iterate from 2 to 12. Okay, so n minus 1. So if there are any factors in between these 2 and 12, then we'll say that it is not prime. Okay, so if it is not divisible from for any numbers from 2 to 12, for 13 for example, then it is a prime number. So 13 is a prime number. So this is the logic we have applied to find out whether the given number is prime. And then I have shown you how to use a while loop. Okay, while loop will be having the initialization condition and the breaking condition. Always you have to see to it that the while loop is pushed towards breaking. Okay, fine, properly by using an increment and or a decrement operation. Okay, so wherein there is a combination of while, if and else and all that is there in this particular program. So this is the regarding the while. Now, so I want to find out the prime number from 1 into 20. So I will be using a nested loop over here. So let me show you how to write the nesting of while. Okay, so I'm writing I is equal to 2. Then I'll say while. So this will be my outer loop. I is less than 20. Then I said j is equal to 2. Okay, 2. And then I'm writing my while, wherein I'm saying j is less than or equal to. So I'm saying I by j. So I'm just writing a logic over here. And then I'm saying if not, then I say I mod j. Okay. So then I'm simply saying break. Okay. And I said j is equal to j plus 1. I'm writing j is equal to j plus 1. I'm incrementing j. Okay. And then I'm saying j, yeah, if j is greater than I divided by j. Okay. So then it means that it is a prime number. Okay. So I'll say print it's prime number. Okay. So then it's a prime number. Okay. So then I'm saying I is equal to I plus 1. Okay, fine. So this is a nested loop. The outer loop is actually used for outer loop is used for finding the prime numbers between 2 and 20. So we want to find out all the prime numbers. So this is the logic of the prime number. So we are iterating the loop, and if there is a factor of the number, you're breaking it, else you are saying it's a prime number. Okay, fine. So there is a bracket over here. Okay. Let me give the number. Okay, the number is I, right? I is prime. Okay, okay, friends, you can see that. So I'm getting the prime numbers from 2 to 20. So you can see 2, 3, 5, 7, 11, 13, 17, 19. All these are the prime numbers. You can see how it has worked out. So the outer loop will take the range. So I want the prime numbers from 2 to 20. So it is giving me this outer loop will do that. The inner loop will do the logic of checking whether the given number is prime or not. You can also use the logic, the basic logic I have given you in the previous example. Okay, so this is regarding nested while and also the while. Now let me show you how this while works with the else. Okay, how this while works with the else. So say I have something like this. Okay, I'll just take a while loop. I is equal to 1, and then I'll say while I is less than 10. Okay, I'll be iterating the numbers from 1 to 10 in the while loop. So inside this while loop, I am writing if I is equal to then 3. So I'm saying break. Okay, so that's it. Is there else? Okay, there is no else over here. In the while loop itself, if I is equal to 3, it will break, and also it will print the value of I. Okay, so I is printed on the screen. Okay, so that's it. It's a very simple program, and don't forget to give this increment. So I is equal to I plus 1. Okay, fine. Now here after this particular while, I'm giving an else, and inside this I'm simply saying else after while. Okay, else after while. That's it. So let me execute this program and show you. So you can see that the numbers are iterated. You can see that the numbers are iterated from 1 to 10 more. Okay, so 1, when it is 1, 1 is less than 10, the condition is true, and it is checking 1 is equal to 3, it is not equal, so it is printing I, which is 1 on the screen, and then I increments becomes 2, 2 is less than 10 is true, comes it's not equal to 3, prints I, 2 is printed on the screen, and I increments and becomes 3. 3 is less than 10 is true. Now we are saying 3 is equal to 3 is true. So what happens is, like, the break executes and the control completely comes out of the loop. But you can see that since the loop is actually intended to execute from 1 to 10 iterations. Okay, so it is intended to execute for the value of I is equal to 1 till 9. Okay, so it is intended to execute from 1 to 9. But what we have done is, we have actually in the middle itself, there is a break statement here, and the loop did not execute to the fullest, but it has come out of the loop. So the else associated with the while will execute only if there is normal finish of the while loop. So since there is no normal finish of the while loop, the else part did not execute over here. Okay, so the else will execute only if the while executes to the fullest and comes out of the loop if this condition becomes false only. Okay, so then only this else will execute. Let me show you that. So you can see that the else did not execute because there was a break here in the while loop. Now let me show you the execution of the while loop. I'll simply take off this break statement here, and you will see that it will execute now. Okay, so the while the else part will execute here. How this else is executing here? So the else here is executing because there is a normal termination of the while loop. There is no break inside, and there is no abrupt termination of the iterations. So that's why the else part is executed. Okay, so the loop is intended to execute from 1 to 9. So there is normal termination. That's why the else part have executed. Okay, so this is regarding your while statement. Okay, so next we will look into how to give the for loops. Okay, so the syntax of the for loop is that, so I have to give for x in range. So the for loop will execute. So the best way to choose the for loop is when you know the number of iterations in advance. So if you want the loop to execute for 3 times, okay, for 0, 1, and 2, then you can use the for loop. So I just have given it. So it will execute for 0, 1, and 2. Okay, so here in simple for, okay, so I'm just giving I over here. So you can see that I'll be getting the output. Okay, so it's X, right? So I just have given I over here. Okay, so that's why it's showing me the error. Okay, now you can see that the for loop is executing for 0 and 1 and 2. Okay, so 0, 1, and 2. So this is like the end, right? 2 minus 3 minus 1, which is 2. Okay, so that's the range. Okay, so 0 to 2. And so this is a simple for, and you can see the syntax. So I'll be giving, this is the for variable, which is also called as the range variable, and this is the range. The range will be given in terms of the range will be given like this. Okay, so it means that 3 minus 1, so it will execute for 0, 1, and 2, and you have to give a colon over here and then an indentation and the statements that you want inside the for block. So this is a simple for. You can also give if and else inside the for, and if you associate an else after the for, if the for breaks in the middle, then the else will not execute. If there is normal termination of the for, then only the else will execute. This is similar to how we have seen for the while loop. Okay, so let me show you that. Say for example, I am also associating an else over here, saying that print okay after for. Okay, so after for, so you can see that since there is a normal termination of the for loop, so after for is also executed in the else part. Okay, so now let me try to give some break condition over here so that you'll understand it. Okay, right, you'll see whether this will execute or not. If x is equal to 2, okay, so if x is equal to 1, so then I am saying break. Now you'll be seeing that this after, okay, so else after for will not execute. Okay, see here that else after for did not execute. This is simple for and also for associated with an else. Now let us look into, you can also give ifs and else inside the for. Okay, we already have seen this. I have given if inside the for. Now let us look into how to give nested for loop. Okay, so how to write a nested for loop. So I have an outer for, so wherein I'm saying for I in range. Okay, so for I in range, I'll be printing a pattern here. So I'll show you how to print a pattern. So then I am saying print. Okay, now I'm giving my nested for j in range. So this is for j in range I. Okay, so one after the other we are taking, give the indentation, and now you say print. Okay, I'll be printing s, and followed by, I'll give some space over here. So let us give some space. Okay, end is equal to space. Okay, fine, let me execute and show you to you. Okay, I haven't given the column. Okay, fine, I have put the column. So you can see that the pattern is obtained over here. Okay, so you can see that the range is executed from 1 to 5, right? Okay, so when I say that it is 6, it means that it is 1 to 5. So you can see that first iteration I is 1, right? So here also it takes 1, prints 1s, and then this range, this for stops, and then is terminated, and it goes to the outer loop, and it takes now 2. Okay, so now I will get 2. So, and in the next case, it will be 3. 3 means that 3 minus 1, 2. So meaning that it will execute from 0, 1, and 2. Okay, so 3 SS are printed and 4 SS are printed, and then the 5 SS are printed. Okay, so this is how the nested for works. Okay, you can see that the outer loop will execute for 1 to 5 times. For each value of I, the inner loop will execute and print the pattern for you on the screen. Okay, so this is nested for concept. Okay, fine, we have finished this exercise. So develop programs to demonstrate decision making. We have seen the decision makings, if, else, and elif and all that. And we have seen the looping structures. Inside the looping structures, we have seen while, for, along with the nesting of while, nesting of for, and also associating else with while and for. Okay, hope this video is helpful to you. Thank you for watching.